Hey everybody and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy where we are learning networks together. And on this part 7 on this series, which is all about EVPN-VXLAN, I always pronounce these acronyms, so I feel like I've got to say again. That stands for Ethernet Virtual Private Network. VXLAN is Virtual Extensible Local Area Network. Two big acronyms in one, as I always say. On this part, on part 7, we are going through the EVPN route type 5. I've actually had quite a few messages to say, hey Dave, what about route type 5, etc. The reason why I've not covered route type 5 up until now is because we needed to lay the groundworks. We needed to give the foundation in terms of what is the IRB, what is the MAC VRF, and actually what are those different EVPN service bundles, such as the VLAN Aware Bundle Service Interface, before we could actually touch on the EVPN route type 5. So this is the last type of EVPN route type that I'm actually going to go through. I'm still going to do more parts in this series, but I'm not going to cover the other EVPN route packets because that's more around multicast and IGMP, and my knowledge on IGMP certainly needs to be a lot stronger before I can even go there. Maybe in the future, but for now we're doing EVPN route type 5. And honestly, I've looked into obviously EVPN route type 5, and a lot of my colleagues tell me it's just an easy thing to get your head around. And yes, that is true. But for me, there's actually two parts to the EVPN route type 5. The first one is, what does it do? What does it provide? And it's basically IP Prefix Advertisement. And we'll come on to more details on what that is in a few minutes, of course. But then there's this second part to the EVPN route type 5 where we start talking about the DCI, or the Data Center Interconnection, or interconnectivity over a WAN. And then you literally open up a huge can of worms, i.e. a lot of potential options which a data center or a environment, a network could go down. So yes, whilst EVPN route type 5 is straightforward in terms of what does it do, what does it advertise, and how does it do it, what it supports is actually quite a lot more and very, very heavy. And that part I'm certainly not going to be covering in this video or at all. So on that note, please refer, regardless of your vendor, your vendor installed in the network, please refer to that vendor's documentation and of course what's in your network, how you want to have that reachability between data centers over that WAN, and pick the right scenario, the right deployment that obviously suits yourself. So on this video, as I said, I'm just going over EVPN route type 5, what it is, what does it do, what's inside the packet header itself, and I will touch a little bit on those different deployment scenarios between different data centers. But for now, let's just actually start off on what is the EVPN route type 5 and generally where is it used. So here we go. Let's start with route type 5 and why do we actually need it. Just I didn't make this diagram. It's obviously quite nice. I didn't make it. I'm not that great at making diagrams, as you've probably seen. So I can't take any glory for this. And hopefully I don't get done for any copyright or any plagiarism, etc. Hopefully, please leave me alone. But what we can see here is there's actually three different data centers. So we've got site A running this particular data center, we've got site C and site B. Now within site A, there's actually two different MAC VRFs, or VRFs as I've got used to calling them. We've got MAC VRF AB and we've got MAC VRF AC. Now what you can also see in the other data centers is there's the same MAC VRFs. So in site C, we've got MAC VRF AC, which obviously needs to have connectivity to and from site A. And over at site B, we've got MAC VRF AB, and of course that needs connectivity over to site A with that same MAC VRF over there. Now, obviously in the middle, we've got this lovely great big cloud, the core IP, which is signifying the wide area network or WAN connectivity, or it could be SD-WAN, whatever it is. And as we typically know in the WAN world, this could be running on different types of protocols. So it could be using something called multi-protocol label switching, MPLS. I don't know a lot about MPLS. I can hold my own, but I know it's quite expensive and it's actually a very complicated technology. But obviously we're not here to discuss multi-protocol label switching. The point is to discuss why we need the route type 5. Now, as we can see in pod 1 over here, there's a number of devices just about here. So you've got these servers here, whatever they are, connected up to these different leaf devices here. This has actually got an ESI lag running here. And then these leaf devices are connected up to a spine. They've got multiple links for redundancy. Of course, you want that in any environment. And just likewise for pod 2 down here, these are then connected up to the super spine. That's what a pod is typically comprised of. So if I just draw it, you have leaf devices and you have a number of leaf devices here, and then you have spine devices and you have a number of spine devices. But as the number of leaf devices grow, they obviously consume more and more ports. I'm not going to draw it for each one, but they consume more and more ports on that spine device. At which point you can deploy more spines, of course, and connect these. But at which point you might want to start deploying super spines. So I'm just going to do SS here for short. So super spines here to connect those spines to and from each other. Now, and the super spines are what we are actually looking at here. But you could also use super spines as border leaves. So these devices could also be border leaves. I'm not too sure. The diagram is obviously quite high level, but whether it be super spines or border leaves, these devices here are providing that WAN connectivity to get out of this great big data center and of course out there, and to give reachability to site C and to site B. But what do we know if we just concentrate on pod 1? What do we know in terms of communication and packet types that are within this particular MAC VRF, i.e. MAC VRF AB? Well, within here, what are you going to have? You're going to have a number of EVPN route type 2s. And I've already done the video on this. If you don't know what route type 2 is, please check out this link. It's all described there. But a route type 2 is basically advertising a MAC address. So that would be the MAC address of the tenant of the server in this particular case. And because this device here is actually multi-homed in route type 2, you will also get that Ethernet segment identifying that this MAC address is behind a multi-homed connection, i.e. an Ethernet segment identifying the identifier is identifying that Ethernet segment. But optionally within the route type 2, and it is an optional field at the end of the day, you are getting the IP address, or you could get the IP address of that MAC address here. It is optional. It doesn't have to be there. And this is provided by the device doing a recursive lookup on its ARP table, where it would see what is the IP address behind that particular MAC address. And the MAC address actually comes from the switching table itself. So there's two different tables there which are used just instantly to actually form the route type 2. And the route type 2 is great, serves a great purpose, and that is, I don't want to say flooded, it's not flooded, but it's communicated to all interested devices throughout the network. And obviously there's not many devices here, but any devices which are participating within that same VNI, the virtual network identifier, for VXLAN, which is an overlay tunneling technology, they will receive these route type 2s to learn, which is an EVPN packet type, to learn, this MAC address is behind this ESI and it has this IP address, and thus they know who's connected to what, where, and if it moves, those are updated via different packet types like the route type 1. But the problem here is, and it's not a problem, but the scenario here, I should say, is that site B has a same MAC VRF with all tenants here, however many there are in MAC VRF AB. Now, do we want to flood all of the, not flood, but do we want to advertise so used to saying flood with Ethernet, I have to I have to adjust many years of habit there. But do we want to advertise all of those MAC addresses from pod 1 up to these super spines, or probably these border leaves here, for then all those MAC addresses to go over that WAN connection, whatever it may be, to these border leaves here, and then out to the network they go? The answer is no. You don't want to do that. You don't want all those remote devices to learn that this MAC address with this optional IP address is connected over the WAN. It's not inside my network, but it's outside of my network. And the reason why you don't want to do that is you've got to think about scalability. And by scalability, I'm not referring to the network design. I'm actually referring to these devices themselves, whether it be the leaves or the spines or the super spines, wherever you're storing that IRB and that MAC VRF. You've got to think about how much that routing table can scale. You don't want to keep advertising all the different MAC addresses for all those different servers, tenants, etc. to all those remote data center locations, because A, it's going to use up a lot of your WAN bandwidth, which of course does cost money, but also it's then going to consume a lot of memory on those receiving devices. And when it comes to troubleshooting, who likes a large routing table at the end of the day? Speaks for itself. And that is where the route type 5 essentially comes into it. And the route type 5 is what's called the IP Prefix Advertisement. So it's quite literally advertising the IP prefix, whether it be a /24 or /26 or /16, whatever it is, it doesn't matter. If pod 1 over here is, just for example, I'm making up numbers here, but if it's a 192.168.10/24, obviously a 10.0/24, and over here it's a 192.168.10.0/24 as well, then we are only advertising these prefixes from pod 1 over to site B, or I should say from site A over to site B, between this MAC VRF over to this MAC VRF. And quite literally that core IP, as it should be doing, is providing that transport. So no longer do we have all those MAC addresses going back and forth and populating all of those tables and entries in that table. No, we don't have that anymore. It's quite literally just advertising the prefix of all the tenants, servers, etc. that fall within this prefix that are in site A and that are in site B and are then communicated over the WAN. Now, of course, this pod here, the spine here, is going to send that traffic on to this border leaf device here, and vice versa for here. This leaf here is going to send that traffic up to what looks like a spine. And here it starts to get a little bit more interesting in terms of the different ways you can advertise the IP prefix advertisement across that WAN. There's different ways you can do that, as I said. But before we go there, let's actually look at what is the route type 5 packet header. And so this is the packet header for the route type 5. Again, I didn't make this diagram. I've actually taken this from a public image that I got from, and it came from Arista. So Arista, well done. I actually really like this diagram. It's actually very helpful. So well done, kudos to Arista. But as you can see here, right at the beginning, we've got a path attribute. EVPN is a family member of multi-protocol BGP. It's IBGP at the end of the day. And within the BGP world, there's a number of different packet types. You've got your update message, you've got your keep alive, you've got your notification, etc. And within the update message, we are defining different path attributes, which would be your local preference, your AS path, multi-exit discriminator, etc., etc. There's lots of them. But essentially my point here is that we are advertising the multi-protocol reachability for this network layer reachability information. So here would actually be all of those IP prefixes, and I think it was 192.168.10.0/24. So that would be actually part or contained within the NLRI. We have the next hop information, etc. And then we've got the address family indicator of 25 to say this is layer 2 EVPN. And the subsequent address family indicator is 70, and that is EVPN. So it's quite literally BGP saying this is a layer 2 EVPN, and we're using layer 2 VPN, and we're using EVPN as the control signaling protocol. But as you can see within the EVPN world, there's then 5 well-known, as I call them, well-known packet types. From 1, Ethernet auto discovery, MAC advertisement, that's route type 2, we just went over that, type 3, type 4, and then the purpose of this part is part 5 here. There are more, 6, 7, 8, maybe higher. But as I said, I'm not going into those until a much later date when my knowledge on multicast and IGMP is a lot more than what it currently is today. I'm just being honest there. But now we can actually see the type 5 network layer reachability information. So as always, you've got this route distinguisher here. The route distinguisher literally identifies, is it a type 0? So you can either have a type 0 or a type 1 route distinguisher. Typically today, it's always going to be a type 1 route distinguisher. And it usually takes the format of the router ID. It's recommended to have the router ID other than an IP address. An IP address can change. Obviously, router ID can, but you don't want to tie an interface IP address to be part of this route distinguisher. And then you're just going to have some kind of arbitrary number here, whatever that may be. So that could be the autonomous system number, whatever. But you're going to have a route distinguisher which identifies where has this update actually come from. And then the Ethernet segment identifier, ESI. Now I was honestly very confused when I saw what an ESI in the type 5 EVPN packet type, because this is already contained within the type 1. It's also contained within the type 2, and it's also referenced in the type 4, where we start talking about a designated forwarder. So why then do we need it in a type 5 when it's just advertising IP prefixes? I'll come on to that in just a second. We've then got the Ethernet tag as well. So this is something that may or may not be advertised depending on your EVPN service bundle. So that's why I've done part 6 where we referenced the VLAN aware service bundle. But if you're using the EVPN based service bundle or the EVPN VLAN service bundle, that tag may or may not be there. That's why I've done that video first. So you may or may not have this tag information. And then we've got the prefix here. So that would then be the 192.168 running out of space 10.0/24 and the gateway. Now the gateway here is of the border leaf. It's the device that is going to terminate a VXLAN tunnel and then do some kind of routing to that customer edge device and then peer to a provider edge device, and over the WAN it goes. But here it is the border leaf. If you don't know what the border leaf is, the border leaf is literally the leaf that's inside the data center or inside that campus fabric that is providing connectivities to some kind of firewall or routing device, which then peers to that service provider. Now, you don't always need a border leaf connecting to a customer edge device. Sometimes you can have that border leaf directly connecting to that service provider PE. Again, it does depend on your topology. Remember where I said big can of worms? Yes. This is where we start opening up a big can of worms where there's a lot of different options. You'll see more in a few minutes. Oh, actually, that was this one here. So yeah, I've got that a little bit confused there. So the border leaf would be that gateway address here, and this is the IP prefix. So the EVPN route type 5, I'm just going to move this down here. So let's do border leaf there, and here we could have IPv4. So I'm going to do v4, or you could have v6. So the EVPN route type 5 can carry IPv4 or IPv6 prefix advertisements. And then you're going to maybe have the multi-protocol label switching label. If you're not using MPOS, this would then be the virtual network identifier. And then we've got, as always, a route target. Now, as I've said in previous videos, you're going to have an export policy, which will export that route target with a particular value. So it looks something like ASN, just for example, and then some kind of arbitrary number. Just for example, you're going to have an export policy with this particular field and value. And then you've also got to have an import policy on the receiving device, which is configured to have that same configuration. If that import policy doesn't match that of the export policy, as I always say, and I have said, that receiving device will drop that information. It's going to basically say and think to itself, I'm not interested in this. I don't have an import policy to take those advertisements, those update messages, and put that into my routing table. So I'm just going to drop it. But that's what a route target is, but it's an extended community because depending on your DCI deployment, i.e. the topology, how you want to carry these advertisements from site A to site B, there's different ways. And you could have here a system MAC address, which actually identifies the MAC address of that border leaf. So the border leaf, you have a gateway IP address here, but you could also have a system MAC address contained within here as well. As I said, big can of worms. And then you've got the tunnel encapsulation. So at this point, you might be thinking, you could do VXLAN. Yes, absolutely correct. You could do VXLAN, but you could also do GRE, or you could also do MPOS. MPOS is tunneling at the end of the day. And here we are defining, or the route type 5 is defining, how we encapsulating this. Is it going over multi-protocol label switching tunnels? Is it going over VXLAN tunnels? Or is it going through a GRE, a generic routing encapsulation tunnel? And there's more. As I said, route type 5 is straightforward in terms of what it does. But when you start looking at how you can deploy it, you get into a lot more information very, very quickly. But for what you need to know for this video is the route type 5 is advertising IP prefixes. That's it. And this is the information that is contained within the the EVPN route type 5. Now, interestingly, these three here, so if I just draw this here, this is what's known as a route key. So I had to Google this. I haven't heard of a route key before. So if a receiving device receives these EVPN route type 5s, and you can see it's got this prefix length, so it's IPv4 or it's IPv6, and this is the prefix itself, so your 192.168.10.0/24, and this is the gateway IP address. If it's got multiple ways, multiple routes to get to that prefix and to that destination via this gateway, what it's then going to do is it's going to use a key, it's going to refer to the path attributes to determine what is the best route to get to said destination, to that destination. So these three here in the EVPN route type 5 are used for a route decision making process. If you have two entries or more basically going to the same destination, and that obviously can happen. And I will touch on why you would see an Ethernet segment identifier here in just a minute. But there are two different types of route type 5. You could have a pure route type 5, so I'm just going to write that out, pure route type 5, or you could have a standard route type 5. I'm just going to do RT5 for short. So what are the differences here? Well, with the pure route type 5, what this is advertising, so I'm just going to do pure here. What this is advertising is the IP prefix information, of course, the IP prefix information, but it's then also using this extended community route target to advertise what is that system, or as it's really called, the router MAC address that has advertised this. So with a pure route type 5, it's really just advertising the IP prefix, the 192.168.10.0/24, whatever it is, and who's actually advertised this, i.e. what is the MAC address of that system, of that router. What is a standard route type 5? So if I just write standard here, the standard will advertise the IP prefix as well, but it will not advertise the MAC address that is contained within the extended community route target. It doesn't advertise that. What it actually does use is the gateway IP address. So I'm going to write gateway here, gateway IP. So the gateway IP address is actually referenced in the standard route type 5. But it needs a MAC address at the end of the day. An IP address is not enough. So with the standard route type 5, you're also going to then have the route type 2, which identifies the MAC address of, well, who's actually advertised it. So there are two different types of route type 5. You've got a pure route type 5, which is, yes, advertising the IP prefix. That's there regardless of the type. But it's advertising immediately where has this MAC address actually originated. So this prefix actually originated from, who's advertised it. With the standard, it's defining an IP address, which is great, it's layer 3, but we still need that layer 2 MAC address, and that's where you need the adjoining, the adjacent route type 2 to do that recursive lookup. So let's come back to this part here, the ESI. Why is there an ESI within the route type 5? There's this concept of what's called the overlay index when it comes to the route type 5. I've read the RFC, which is RFC 9136. Let me check. Yeah, RFC 9136. I wanted to be precise there. And it does talk a lot about this overlay index. And I don't know about you, but I struggle to read RFCs. They can be a bit, at times. But they're insightful nonetheless. However, what the overlay index basically defines is if you want to get to this border leaf, or if you want to get to that spine that has the IRB interface that is doing that routing over the WAN, or whatever the topology is, there's multiple ways you could get to that border leaf, to that spine, whatever that device is that's providing that WAN connectivity via the IRB, the integrated routing and bridging. Again, refer to this video if you don't know what IRB actually is. And what the overlay index basically defines is you could actually advertise that route type 5 via an ESI. But if you are advertising that device, which is advertising this prefix through the ESI field, guess what? That device, that receiving device of this route type 5 needs a route type 1. So you need a adjacent or adjoining route type 1 to know and to complement really that ESI, because the route type 1 is all about auto discovery, mask withdrawal, aliasing, and through all of those you get that ESI. It's a dedicated ESI EVPN packet type at the end of the day. What it also defines is you could use a gateway IP address. Now, to have the gateway IP address, what do we need? What does the receiving device need to have received previously, or at the same time, or at a later time? Very, very small thresholds, obviously, between receiving this route type 5 and this route type 2. The gateway IP address is defined via the route type 2, because within here there is a MAC address or optionally an IP address, and it is here that the gateway IP address is actually defined. So even though it's optional in the route type 2, it has to be there if the overlay index in the route type 5 is that of a gateway IP address. Wow. And also, I don't know if I've said it already, but the extended community here, we've got that router, I'm just going to do RTR for short, or system MAC address here. What advertises a MAC address? I've already mentioned it, but it is that route type 2 again. But here we would be using the MAC address that's contained within that route type 2 and not that optional IP header. So that is why you could see an ESI. That is why you could see a gateway IP address. That is why you could see an extended community router-system MAC address. Now, I highly recommend you refer to the RFC 9136 because there are variations of this. And here's an extract of the RFC. I'm just going to write it out. 9136. I'll put a link to this down in the more field or the comments box, whatever. But here's just an extract. So it's literally saying if you have the ESI within this route type 5, then the gateway IP address must be 0. The MAC address must be 0. The MPLS label or the VNI label, I don't care about that. But that's when you're using the overlay index to use that of an ESI. Likewise, for the gateway IP address, if the gateway IP address is a non-zero, the ESI has to be 0. The MAC address has to be 0. So as you can see, there's different ways to advertise this IP prefix advertisement. You've got your pure and standard way of doing it, but you need those other EVPN packet types to really support this. And there's different ways for that receiving device to identify how to get to that advertising border leaf, the advertising spine, i.e. is it via an ESI? Is it via a gateway IP address? Is it via not an MPS label, but that would be, it's obviously referenced here. Or is it via a extended community router MAC address? And the RT then defines if you have a non-zero for this particular field, then these other fields might be 0 or should be 0. So yeah, a lot contained within this route type 5. As I said, my colleagues have said to me, it's pretty standard. It's just advertising prefixes. Yes, but when you look into it, it's a hell of a lot more. And so I'm coming back to this topology now, this diagram, now that we've touched on what the route type 5 is and the packet headers and the variations of the route type 5. I just want to go through the different ways that you could deploy the route type 5. So as we know, we've got site A, site B, site C, and there's two different MAC firsts. We've got AB, AC here, and we've got MAC VIF AC at site C, and we've got MAC VIF AB at site B here. Now, with the deployment, there's different ways over the WAN that you could carry potentially that route type 5. So what you could do is you could do stitching or VXLAN stitching across the RAN, and this could be at layer 2 or layer 3. Come on to that in just a few minutes time. But as I've also said, this could be multi-protocol label switching, or it could be GRE, generic routing encapsulation, or it could be OTT. And there's one or two other ways of carrying this information over that WAN, which is essentially a data center interconnection at the end of the day. Now, depending on your deployment model, it really dictates what happens to this VXLAN tunnel. So if you're using multi-protocol label switching over this WAN, then the VXLAN tunnel, if I just draw it here for site A, it really stops coming from those spines up to these border leaves or super spines, whatever they are. It really stops there, and then you're going to have a provider edge router which the CE router peers to, and it will advertise that information, and then over the multi-protocol label switching or MPLS network it actually goes. And it's really the same for GRE. I don't know much about OTT to give any kind of statement here, but what if you're doing VXLAN? Well, if you're doing VXLAN, what there is, and I like to think of it as a transit tunnel, just like when we were talking about symmetric IRB, where you had that transit VXLAN tunnel to go from that egress, or technically the ingress leaf, to the egress leaf via the spines. You've got that transit tunnel. For me, it's the same kind of concept in my mind. We've got here, if we just look at site A, and we want to get from MAC VIF AB over here to MAC VIF AB over here at site B, we've got these tunnels which will then come up to this border leaf. I'm just going to call it a border leaf here. So let's just call this a spine, and let's call this a border leaf here. And then those tunnels will terminate there. Then this device will build and have a transit tunnel which goes over that WAN connection, and it will have a different VNI actually assigned to it. And then you can pass your layer 2 traffic over this, so layer 2, or it could be layer 3. Why would you need either? It really depends. If this bridging domain, which is aligned to this MAC VRF, is contained within this data center. So if MAC VRF AB is contained within this data center, so let's just say this over here was MAC VRF AD, for example, then we wouldn't need to provide layer 2 tunneling, because these are different MAC VRFs now. So we've got MAC VRF AD here, AB there, but now we've got MAC VRF AD over here in site B. So there'd be no real need to provide layer 2 tunneling. So layer 3 in such a scenario would be more than enough to advertise those prefix information. But if this was AB, as it actually is in the diagram, then layer 3 might not be enough. You would actually need layer 2 to stretch that layer 2 VXLAN tunnel from pod 1, site A, over the transit tunnel, and out it goes at site B. So again, remember what I said during the introduction, the route type 5 is quite straightforward in what it does. But when you look at the RFC and when you look at the deployment models, it gets a hell of a lot more information very, very quickly. And that's why I highly recommend, and want to reference this again, please read that vendor's documentation and their validated design. It may change from vendor to vendor. I don't know, to be honest. But again, just check documentation. And so I just want to show this very quickly. These are actually different options, 6 different options from Juniper. Just very quickly, and this is just to support what I just said, where you need to check documentation. So option 1 was actually where we have a VLAN handoff at that CE, and then we've got a multi-protocol label switching, providing layer 2 DCI over the WAN. Option 2 is where we're using OTT. I don't really know much about OTT, to be honest, and as I've said, so I'm going to skip this very quickly, but note OTT is a deployment scenario, it's a deployment option. Option 3, which you can see a tick here, is something that's recommended from Juniper. So this is where we're providing a layer 2 DCI, and again the VXLAN tunnels terminate at that border leaf. But then we've got a new tunnel, a transit tunnel, going over the multi-protocol, over the DCI, over the WAN connection, not MPLS, apologies. But this is providing a layer 2 DCI, layer 2 for EVPN to EVPN VXLAN, seamless stitching. Option 4 is again with multi-protocol label switching, but unlike option 1 where it was a VLAN handoff, now we're actually stitching the VXLAN tunnel to an MPLS label. So you're going to have VXLAN tunnels coming up here, and then you've got multi-protocol label switching, which is stitching that VNI to an MPLS label. Sounds a lot more complicated and more to configure, and MPLS we know is not particularly cheap. When it comes to option 5, again it's recommended. This is EVPN to VXLAN to EVPN VXLAN stitching, but it's now at layer 3, where option 3 was layer 2. Option 3 was layer 2 here, and option 5 is layer 3. And finally, option 6 is where we've got the route type 5. On option 5 was advertising route type 5 as well. Option 6 is advertising route type 5, but again over an MPLS network, and this is at layer 3. So just in summary, you can see from Juniper, and this may vary from vendor to vendor, there are different deployment scenarios, there are different deployment options. Ultimately, check documentation, refer to your vendor's documentation, and investigate what would work best for your network, your deployment, your architecture, and what kind of reachability you actually want to have. And obviously there's many different variations on all those different use cases there. And so there we go, everybody. That is the end of this video. That is the end of part 7, where we've gone into EVPN route type 5. Honestly, this has taken me a long time to build up to this route type 5, because I had a feeling that it was going to be a lot more complicated than people generally feel that it is. In summary, yes, route type 5 is all about advertising an IP prefix, a /24 in this video. We've done a 192.168.10.0/24, but it could be ever, and it really doesn't matter. It's about advertising the IP prefix. But as we also then discovered, there's two different types of route type 5, where we've got that pure route type 5, which is advertising, yes, that prefix, but then it's also using that extended community to advertise that system-router MAC address. And then we've got that standard EVPN route type 5, where we needed that adjoining route type 2 to have that MAC address. And we very quickly then discovered that actually there's a lot more to this route type 5 in terms of those deployment scenarios. In summary, though, route type 5 is very powerful, and it really decouples that receiving device to learn all of those MAC addresses for all those remote tenant servers, virtual machines, etc., when it could just learn an IP prefix at the end of the day and see, this IP prefix, I can get to the IP prefix via this route, and ultimately via that border leaf dash spine, depending on your architecture. So I hope you found that useful. I hope you found that informative. If you like this content, please give me a thumbs up. Best way to support my channel. Any questions or comments, just let me know down in the comments box. I always try to respond. Other than that, thanks for watching and goodbye.